Alright, we're starting a series of videos now looking in depth at quadratic functions. And just to show you where quadratic functions fit into other things that we know about, in the past you've talked about linear functions, which are first degree relations. And the look of a linear function is y equals ax plus b, where a and b are real numbers. Sometimes we say y equals mx plus b, where m is the slope, b is the y-intercept. Okay, and we know that the graph of a linear function is a line. So a quadratic function is a second degree relation, and it has its own shape as well, as we're going to see. And the general look of that type of function is ax squared, the power goes up by 1, plus bx plus c, where a, b, and c are real numbers. And a can't be 0, by the way, otherwise this would reduce to a linear function. Now, just to take an initial look at what the shape of such a graph would be, I have an animation here that allows me to change the values of a, b, and c to different numbers, and this changes the graph. So what you can see right here, what I have set up is I have the equation 2x squared minus 4x minus 2. If I were to build a table of values with this equation, I would get this particular graph. And as I change a and b, so let me change a, you can see that certain things are happening. Graph's getting skinnier or wider, or sometimes it's going downwards. If I change b, it's changing the position of it. If I change c, it's changing the position of it again. But throughout all of this, the basic shape of the graph stays the same. It's this curve, which we call a parabola. So the graph of a quadratic function is always a parabola. So before we get into building these graphs, let's just look at a few different equations and be sure we can identify which is quadratic and which is not. The defining feature, remember, is that it's second degree. So if I go through the first term, the degree of this term is 2, the degree of this term is 1, the degree of this term is 0. So the degree of the polynomial we know is the highest of those, which is 2. So this is a second degree. It's a quadratic relation, which means its graph will be a parabola, opening up or down. Okay. The second one, well, right away I've got a third degree. Alright, so this is a different looking graph, which we haven't studied yet, so this is not quadratic. Down here we have variables in the denominator, but you'll notice that from the look of my equation, it must be ax squared plus bx plus c. No variables in the denominator allowed. So again, this is another kind of function. It's not quadratic. Similarly with the next one, 1 over x to the negative 2, because if you were to write it with x up above, that would be x to the negative 2. That is not degree 2, so that is not quadratic. Next one, square root of x. Again, square root of x can be thought of as x to the 1/2 as a power. So that's not second degree, so that graph is not quadratic or a parabola. And the last one, it is. We have a one term, it's second degree, so the graph of that would be a parabola. In fact, it would look something like that. Alright, some important terminology related to quadratic functions and parabolas. So I have a graph here. We should always have arrows on the end to show the graph will continue on. Alright, the vertex is this point right here. It's the high or the low point on the graph. So in this case, I'm situated at 1, negative 2. That would be the coordinates of the vertex. The axis of symmetry is the line about which we could reflect the graph and it would match itself. So the axis of symmetry is this line right here. Okay, if you fold your parabola across that, it's going to match itself. So by axis of symmetry, what's the equation of that line? X equals 1. Alright, X-Intercepts, which we call the zeros of the function. That's probably a new term for you, zeros of the function. Just means the X-Intercepts, where the graph is crossing the x-axis. And a quadratic function will often cross twice, as this one does. So right here at about 2.4, x equals 2.4, and x equals negative 0.4. So you just list those. Depending on the position of the parabola, we may have no x-intercepts. There's an example of that. Or we might have one x-intercept if it just touches the axis. Okay, but more about that later. The y-intercept, where the graph crosses the y-axis, that's nothing new, -1. Alright, now because of the shape of a parabola, it will always have a minimum or a maximum value. And when I ask for this, I'm asking for the y value that's the highest or the lowest on the graph. Well, because this particular parabola opens up, the lowest y value is therefore a minimum, and the minimum y value we can see is -2. So the minimum value is -2, happening when x equals 1. But the minimum value, when we're asked for that, is just the y value. Domain of the function, here's a term we've seen before. Which values of x are being used by this particular relation? All of them, so x is any real number. And which values of y are being used? I can see that the lowest value of y is -2, as we said, and it's any value of y greater than or equal to -2, where y is a real number.